Today we are going to see about the lecture on Kinematics of Machines. The topic is Basics of Mechanisms. I am Dr. K.S.Rangasamy, Professor, Department of Mechanical Engineering, K.S.Rangasamy College of Technology. So today we are going to see about Kinematics of Machines. The word Kinematics of Machines is from Theory of Machines, where we have two major categories. One is Kinematics of Machines and another one is Dynamics of Machines. Previous one, that is Kinematics of Machines, is study of relative motion between the various parts in a mechanism or a machine. Right? Later part, the Dynamics of Machinery deals with the various forces involved in the various parts of the machines. So the forces may be static and dynamic. Right? The static force analysis means we are not going to consider the inertia forces. Dynamic force analysis means we are going to consider the inertia forces. In kinematics of machinery, we are going to deal with the determination of displacement, velocity, acceleration of the given mechanism or a machine. In dynamics of machinery, we are going to consider the force which actuates the different parts of a mechanism or a machine. Then we have to know the difference between the mechanism and machine. So mechanism is a combination of links, pairs and joints, whereas machines are concerned, they are a combination of different mechanisms. So for example, if you take engineering mechanics, the particles have no specific shape, but they have some kind of mass. Whereas rigid body is concerned, it will be having solid shape and size. Similarly, here in mechanism, the mechanisms are basic elements of a machine. The mechanism will have basic elements like link, pairs and joints, whereas the machines will have combination of different mechanisms. So after that we are going to see about the constrained motion. So for any motion we have 6 degrees of freedom. In that 60 degrees of freedom, my output should be in 1 degree of freedom only. As far as machine is concerned, for example, if you take an engine, our input will be the rotary motion of the crank. The output will be rotary motion of the wheel on the road. So from the crank rotation to output, the wheel rotation on the road, we have different mechanisms. Especially if you take in engines, we have different mechanisms. For example, the crank will be in rotary motion, the piston will be in reciprocating motion. The connecting rod which connects the crank and the piston will have a different motion. Right? So like that, the output of our mechanism should be in a single degrees of freedom. So for that we have to study about the constrained motions. So there are 3 types of constrained motion. One is completely constrained motion, second one is incompletely constrained motion, and third one is successfully constrained motion. So completely constrained motion, which is defined as the motion between a pair is limited to one direction. For example, if you take that example, the square bar in a square hole, the shape of the square bar will be pushing into the square hole. It will have only 1 degrees of freedom, that is, it will be sliding in that hole only. Right? So the shape of the square itself constrained motion, it should have a sliding motion only, not rotary motion. Similarly, if you take another example where we have a shaft in a collar, so shaft means we have a circular cross section. If you insert a circular cross section in a circular hole, it will have 2 degrees of freedom. For example, it can rotate and it can sliding inside the hole. So we have to avoid the 1 degrees of freedom, which is a sliding motion. So for that I am going to put collars on the both side. So it will arrest the sliding motion of the shaft inside the circular hole. So this is how we are converting the more number of degrees of freedom into a single degrees of freedom. So that is called as completely constrained motion. So next one is incompletely constrained motion. If you take previous example, we have a circular bar in a circular hole. So in that we have 2 degrees of freedom. One is rotation and another one is sliding motion. So this constrained motion is called as incompletely constrained motion because it will be having 2 degrees of freedom. So for we need single degrees of freedom means we have to arrest the sliding motion. So next one is successfully constrained motion. So the motion between the elements forming a pair such that the constrained motion is not completely by itself. For example, if you take this footstep bearing, the load on the shaft will be constrained inside that circular hole. So this is called, we need an external force or external member to constrain the motion, which is called as successfully constrained motion. If you take cam and follower mechanism, here we have a pre-stressed spring which is doing a function of the constraining the follower which is on the cam. So next we will see about the different parts of a mechanism. The basic part of any mechanism is link. So link is nothing but a rigid body. Maybe it may be a deformable body, but as far as our analysis is concerned, we are taking that link is a rigid body, where we are link is not deformable body because during the motion it will be having some kind of a deformation, but we are not going to consider that. So link is defined as a member or a combination of members connecting other members and having motion related to them. Right? So link is a connecting body where we are going to connect with another link. So link element need not to be a rigid body. So it must be a resistant body. So resistant body means it will capable of having small amount of deformation while transferring the load or forces. So there are two main characteristics of links. So first one is it should have a relative motion and it must be a resistance body. So there are types of links. The basic types are binary link, ternary link and quaternary link. Binary link means we are having two endpoints. So the link will be connected with another two links. So at the end we are having nodes. The ternary link we are having three nodes at the end where we are going to connect three links with this ternary link, and another one is quaternary link where we are having four nodes at the ends. We can connect four links. So another types of links are rigid link, flexible link and fluid link. So rigid link means as far as machine tools are concerned, we are using this type of rigid links. For example, if you take a piston, connecting rod, crank and some other machine parts. For example, if you take a shaper head, it is also a rigid link. Right? Flexible links means, for example, if you take belt, rope and chains, these are our flexible elements which are going to transfer the rotary motion from one shaft to another shaft. Then fluid link where we are using the hydraulic presses, jacks and brakes are fluid links. With the help of a fluid we are going to transfer the motion. So these are the examples of these links. So first one is your rigid link, and second one is your flexible link, and third one is our fluid link. And this is an example of different types of parts which are using in valve actuating mechanism. Then we are going to see about the joints. So joints are nothing but the connection of two links. Right? So at the endpoints we have nodes. The nodes of two links will be connected at a point which is called as joints. They are only the connections. So there are different types of joints. So first one is binary joint, then ternary joint, then quaternary joint. So binary joint means two links are connected in a same connection, which is called as binary joint. When we are having three links are connected with one joint, this is called as ternary joint. When four links are connected with one joint, it is called as quaternary joint. So next one, kinematic pair. So if we have a link, then only we will convert that link into a kinematic pair. Kinematic pair means where we are having relative motion between the two links. So there are different types of kinematic pairs are available in kinematics of machineries are concerned. That depends on the relative motion between the links. So what will be the relative motion between the link? So we will have sliding motion, we are having turning motion, and we are having rolling motion, we are having screw pair and spherical pair. And next one, according to the nature of contact between the links, lower pair and higher pair. The next one is according to nature of mechanical constraint between the links, closed pair and unclosed pair. For example, first one, if you take sliding pair, the motion between two links will be in a sliding motion. Example, if you take the piston and cylinder arrangement where piston is fixed inside the cylinder, the piston will be sliding inside the cylinder only, that is called as sliding pair. You can see the example here. So if you take that example, it's a pentagon bar inside the pentagon shaped hole, it will be having sliding motion only. Next slide, if you see the turning pair, where we are having rotary motion, circular hole, and we have a circular shaft, it will be having a two collars at the ends, it will be having rotary motion inside the element. So two elements will be having rotary motion. So this is rolling pair. The best example for rolling pair is your ball bearing. Not only ball bearing, if you take wheels on the road, it will be having rolling pair only. So one element is rolls over the another element. So one element should be fixed, another element should be free. The best example for rolling pair is ball and roller bearings. So screw pair, you can see here we are having 2 degrees of freedom. 1 degree of freedom we have to arrest. For example, if you arrest the net, the bolt will be having a sliding motion and as well as a rotary motion on the shaft. The lead screw mechanism in the lathe is example of this screw pair. Then spherical pair, everyone seen the pen stand. It's the best example for this spherical pair. So where we are having 3 degrees of freedom, all the 3 degrees of freedom are rotary motion only. So we have 3 translating motion, we are having 3 rotary motion. So totally 6 degrees of freedom we have for a free body. So especially in spherical pair, all the 3 degrees of freedom are rotary motion. So next one, according to the nature of contact between the links. So first one is lower pair, where we are having surface contact between the elements. So if previously we have seen the sliding pair, rolling pair, then spherical pair, all these pairs are comes under lower pair since they are having surface contact with each other. Then higher pair, if you take a cam and follower mechanism, the higher pair, because it will be having point or line contact between the elements, so it is called as higher pair. So this is examples of lower pair and higher pair. Here we are having the surface contact between the element, and here we are having point or line contact between the elements. So last one, according to the nature of mechanical constraint between the element, self-closed or form-closed pair, the shape of the link itself having a form-closed. For example, if you take a square hole in a square bar inserted in a square hole, the shape of the square rod will itself constrained. So it is called as form-closed or self-closed. So second one, force-closed pair or unclosed pair, we are having external force or we are having external element to have a constrained motion. It is called as unclosed pair or force closed pair. The example is cam and follower mechanism, where we are having a pre-stressed spring to constrain the motion. So next one is kinematic chain. So the connection of the links, pairs and joints are called as kinematic chain. Right? So there is a formula to calculate the motion of the kinematic chain, whether the kinematic chain is constrained or unconstrained or over constrained chain. For that we are going to use this formula. L is equal to 2p minus 4. L is nothing but your number of links, p is nothing but your number of pairs. If you have relation between the joints and links, we can use the next formula. J is equal to 3 by 2 into L minus 2, where J is your number of joints and L is your number of links. So this is an example. If you see, there are 3 number of links and 3 number of joints. In that we are having 3 number of pairs. if you substitute that value in first formula, L is equal to 2p minus 4. We are having 3 links and 3 pairs. So L is equal to 2p minus 4. The answer will be 2. So LHS is greater than RHS. So it means it's a locked chain. So we don't have any motion with the help of this chain.